So let's round out our discussion of access control lists with what I consider some advanced access control list topics. And they are advanced for the CCNA level. Obviously, for people that are getting CCNPs and CCNA and CCNP securities, this is probably one of those, well, duh, kind of moments. But for the CCNA that may have never set up an ACL before in their life, these are some advanced topics and helpful pointers to keep you from just totally ruining your network when you're trying to modify advanced access control lists. One of the uses of access control lists are to restrict telnet and SSH traffic to a router. Now, you normally would only want to restrict that access to just your management networks. You know that all of your network administrators generally stay in one building, and so you'll want to only allow those people telnet and SSH traffic into your router. Now, obviously, since you're filtering on specific ports, you'll have to use extended access control lists. And again, if you know the difference between a standard and extended, it's one of those, well, duh moments. And some people might build an access control list that checks for all of the router's destination IP addresses, whether it's loopback or serial or Ethernet. It checks on every inbound interface, and you update this ACL every time an interface IP changes, or you add a new route, or so on and so forth. That can be very, shall we say, labor-intensive. The more logical way of doing this is to restrict telnet and SSH on the VTY line. Quite simply, VTY lines are used for remote connection, so you can go into line VTY 015 and specify your access control list there just like you would any other interface. And that way, no matter what interface you're coming across, no matter how you're getting to that router, what IP address you're using to get there, this access control list will apply to that traffic. The next bit of sage advice we'll pass along is to remove an ACL from the interface before you make any changes. You use the no IP access group and the number or the name command on the interface to disable processing, modify it, and then re-enable it. This prevents you from filtering packets you don't intend to filter, because you remember you have that implicit deny all at the bottom. So if you remove an access control list, you obviously open up all the traffic across that router interface. The moment you go into the access control list and you enter the first line, you're automatically denying every bit of traffic except that one criteria that you entered in that first line, which means anything else just gets blocked. Obviously, if you happen to be coming from one of the networks that's being blocked or across one of the interfaces that's being blocked, you've just lost remote access to your router, and hope you've managed to do a reload in 10 before you initiated all of this, or that you have someone you can send out to the remote site to power cycle it. Been there, done that. I've got a whole box full of t-shirts. I'll send you one if you want me to. The next bit of advice I'll pass along is to use a text editor to create and modify your ACLs. That's not as important in iOS 12.3 and above, since you can modify the ACLs based on the line numbers. You can go into the access control list and do no 10 and it just removes line 10. Or you can put a line 11 and then remove line 10 afterwards, whatever floats your boat. However, using a text editor allows you to see the big picture before you actually implement your ACL. And to keep in line with our previous bit of advice, always begin your text file with no access list and the number to remove the ACL before you add it back. So finally, let's talk about some other access control list types that exist on Cisco routers but were not covered in the CCNA because, again, they're a little more advanced. The first is a reflexive ACL, or a RACL. You can use RACLs to perform basic stateful firewalling functions in an iOS-based router. Essentially, reflexive ACLs react to the first packet in a traffic stream and dynamically modifies the ACLs on the outgoing interface to allow the reply traffic back. All of this allows you to have tighter control on what traffic comes into the network, because you can block all of the traffic inbound and use a reflexive ACL to open up the reply traffic from a specific host. And again, if you have a stateful firewall like a PIX or an ASA or a non-Cisco firewall, the firewall will take care of this for you. You don't have to worry about setting up reflexive ACLs in the firewall. Next are dynamic ACLs. Dynamic ACLs can be used to allow for dynamic IP addresses, such as VPN connections, DHCP lease expiration, so on and so forth. Obviously, when you set up an ACL, you have to specify a source IP and possibly a destination IP. If that source IP changes, now the user can't get to the remote site or can't get to the application. They're calling you up saying, hey, I could telnet to this host yesterday and I can't today. What gives? and after 30 minutes of searching, you figure out, oh, their IP address changed, and you got to go change the ACL. Essentially, dynamic ACLs tell a user to telnet into the router and give a specific login name and password. The router then sees what IP address you're coming from and modifies the ACL in question to allow your traffic for a period of time. And once you've stopped using the host, your traffic times out and that ACL is removed. The last advanced ACL type is a time-based ACL, and that's exactly what it sounds like. It's an ACL that is valid only for certain times of the day. So let's say you want to block all traffic to Facebook.com between 8 and 5, but after 5, if someone's working late, yeah, you'll let them go out and update their Facebook status because they're putting in the extra hours necessary, and so you'll suspend that ACL after hours. That concludes our discussion of advanced ACL topics and our discussion of access control lists.